Hi friends, welcome to follow up. Let's have a look at problem 2860, happy students. In this video, we are going to explain a solution based on the strategy, thought, and scheme. So here we are given an array representing students. So we want all the students to be happy, and we want to find the number of ways to select a group of students so that everyone remains happy. So this statement is very important. We want to make sure every student remain happy, right? So here the ith student will become happy if one of those two conditions is met. So first, if the student is selected, and then the total number of select students is strictly greater than the nums I, right? So if the student is not selected and the total number of select students is strictly less than nums I. But also we want to understand this requirement in together with this requirement. So we want every student to remain happy. So once we can realize these 2 points, so actually finding a solution is not that challenging. So here we have 2 examples. So let's first look at example 1. So here we have 2 1-1s, right? So if we do not select any students, so we want that 0, this is the number of students selected, less than every number in the list. So 0 is indeed less than the ones here. So this is one possibility. Another possibility is that we want to choose all the students, or both the students, because here we have 2 students. So in this case, 2 is indeed greater than the ones. So this is the second case. This is the output. We cannot choose one student. So if we choose 1, so we want the select students is strictly greater than this number, but 1 is not strictly greater than 1. And also this one is not selected. We want the selected students should be strictly less than this one, but 1 is also not strictly less than this one. So this is the 2. For the second one, we are going to give a digest later. So here the constraints are the following. First, the length can be very long, so as long as 10 to the power 5. And secondly, so the elements is non-negative and less than the length of nums list. So with that said, we are ready to do the coding part. So here the strategy we are going to use is thought and scheme. It's based on the 2 observations. First, if a student, let's say I, so let's assume nums I equals x for convenience. If this student is selected, then all the students, say G, with nums G less than or equal to this nums I or x must be selected. So similarly, if a student with nums I equals x is not selected, then all the students with nums G greater than or equal to x must not be selected. So for both of the 2 observations, we can argue by contradiction. So we want to show that all the students less than or equal to x must be selected. So first, the assumption is student I is selected, right? Let's assume this n selected is a student we selected. So this should be strictly larger than nums I. So now if the student G with this assumption is not selected, then the selected student should be strictly less than nums G. But nums G is less than or equal to nums I, right? So together, this is a contradiction. It's impossible n selected is on one hand strictly larger than nums I, but on the other hand less than or equal to nums I, right? So using the same argument, you can check the second observation. So with that said, so we could sort the nums from small to large, right? So if you look at the index, then basically the big point is that all the students left should be selected because they are corresponding to smaller nums value. And then we look at each index for it to be selected. But due to the above 2 observations, the same if the students have the same nums value, right? Then all of them should be selected simultaneously or not selected simultaneously. So in this regard, only the largest index will come into play. For example, here 0 and 2 appears just once, so there's nothing to see. So the index are 0 and 1. But for 3, we are only focused on this index, that is 3. For 6, we are going to look at index 5, and for 7, we are going to look at index 7. Now let's look at each check. So if we do not select any student, so we have 0 students selected, but 0 is not strictly less than 0, so this is not possible, right? So if we select all students, this 8 students, it is indeed greater than all the numbers. In particular, it's sufficient to say it's larger than 7, so it's okay. So we can select all students, right, corresponding to this case. So now let's look at each key. So for key 0, so if we select this key, so it means that we select one student. So this one student is greater than the number, that is 0, and also less than the next one, that is, those are non-selected. Because it's less than 2, it's less than 3, 6, and 7 naturally. So this is an okay case. So for key 2, so index is 1, meaning that if we select it, we're going to have 2 students selected. So this 2 is not strictly larger than the key, that is 2. So this is not okay. We don't need to do further check, right? At k equals 3, the index is 3, meaning that if we select this value, and then the student selected will be 4, right? So 4 is strictly greater than the number, that is 3, and strictly less than that next key, that is 6, right? So this is the okay case. So for k equals 6, the index is 5. It means that we select 6 students. 6 is not strictly larger than this value, that is 6. So we do not do further check, so this is not okay. So this corresponds to select all the cases. So overall, we have 3 okay cases. So if you look at the check for okay case, so though these 2 conditions here, so we see that one of those 2 conditions is met. But because we require every student remains happy, we need to check the 2 conditions simultaneously, right? So this is the check here for this one. We need to compare the number of select students with the current key and the next key. So with that realized, let's look at the coding part. The coding part will be simple, but we want to write with some details. First, I'm going to sort these nums. So after we sort, we want to get the this thing, the value and the corresponding indices. For this, I'm going to use a for loop for I and y in enumerate nums. So here we can choose start from 0. This is the natural one, right? Start equals 0. But if you don't want to do so, index at 1, let's say it's 2, right? Index 3 here is 4. So you can start from 1. But this is a for detail, right? Small detail. And then what we are going to do? So we are going to do d of y equals I. So this way, the result will be, if we have multi occurrences for value, we are going to pick the largest index. So once we done this, so we can try to prepare the return. So result is 0. So now let's look at the keys. Here I'm going to sort this key again. So d keys. This is for convenience, right? And then first I want to check some special case. If we do not select any student, the number of students selected is 0. So we want this to be less than any number in the nums list. In other words, it's smaller than smallest key. That's case 0. So we are going to increment the result by 1. So this case corresponds to select no students. So next case will be another one, select all students. So in this case, we want this one, the length of this nums. So this number of students we selected should be greater than all the numbers. So this corresponds to greater than this one, right? So we are going to increment the results by 1 again. So now let's look at the general loop, general case, or general check. So for this, I'm going to do for I in range. So I'm going to use length case -1. So here I'm going to explain why we use -1. The reason is that we want to do this comparison. So if we select this number corresponding to the key, that is the case I. This case I will be the number, right? So this is the index plus 1, because here we are starting from 0. So this is the number of students selected. It should be greater than nums I, that corresponds to the case I. And it should be strictly less than the next key value, that is case I plus 1. So here we have a I plus 1, that's why we are using minus 1 here. So that's why we isolate this case and isolate this case, right? So if this is the case, we are going to increment by 1. All other cases, so we do not, they do not form valid selection. So once this is done, we're ready to return the result. So before we do anything, let's first do a check. Sorted. So I have this, and then let's check generic case. Yeah, in my first 2 tries, I forgot to compare this comparison, so that makes the several cases not passed. So here, as I mentioned, here if you use 1, start from 1, you do not need to add 1 here. So let's test. Yeah. So let me recover starting from 0, and here add 1. So this is a small point, but it's good to notice. So with that said, basically I guess that's about it for a solution to this problem. But if you want to write a short code, you do not need to specify this key unique value as the largest index dictionary. You can directly work on the sorted array. So that's actually also very straightforward. It's good practice. So with that said, that's about it for this video. Thank you.